Welcome to module 45 of Database Management Systems course in the IIT Madras online BSc program. We have been discussing about indexing and hashing to make the accesses faster, and in the last week we talked extensively about hashing, particularly the static and dynamic hashing schemes, and we compared the ordered indexing with hashing. And we also took a look at a nice way of representing or making sure that you have fast access of columns which has limited number of distinct values using a reverse mapping called the Bitmap Index. To close on this notions of indexing, we will in this module take a look at how do you create index of various kinds in SQL, and also discuss few guidelines for what you should index, how you should index, and what you should not be doing. So, index definition and guidelines. So, we start with the index definition in SQL. So, to create an index in SQL, it is SQL style you have understood by now. So, if you have to create anything, you have create, then you say what you are creating, that is index, give a name to that index, and then you have to specify on which file, on which relation are you creating it. So, you give a name of that relation, and finally, you specify the list of attributes which would be used in creating this index. It could be one attribute or more than one attribute, that is, an index could be simple or it could be composite, and we will come to the different issues of that, but this is the basic structure. So, the example, as the example says, create index, this B index is a name, and we are creating index on a relational file called branch and using branch name as the attribute to be used in the index. You can also specify unique while writing the index to indirectly specify and enforce that the search key is a candidate key, because if it becomes unique, it means that there cannot be duplicates of that value in the field. It may not be required in SQL if the unique integrity constraint is supported. If it is supported, use that in your table design and do not have to use it in the index. But if it is not there, then you can also handle it for specific index like this. To delete an index or drop an index, it is called drop index, like you have drop table, and give the index name. So, this is the basic two commands to create and drop index. It also, the index also optionally allow you to specify the type of index and the type of clustering. You could create an index for a cluster, you could create composite index on multiple columns. Maximum limit supported in SQL is 32 columns. Of course, you would never in real designs you will hardly require that. So, the composite index key, since you can have multiple columns involved, will become large. So, there is a restriction that it cannot exceed roughly 1/2 of a data block. Of course, there is some more, it has to be little less than that, because some overhead data will also have to go in there, because otherwise if it is more than half, then you cannot keep the other information. So, this is a basic way. So, to take more examples and showing you the options. So, you are creating an index emp underscore name on employee table using the ename attribute as your indexing field. So, this will just create the index with default options, but you can specify a number of options. Some key ones I have mentioned here. One is you can specify the table space. We did not talk about table space. Table space is basically when the database is organizing its physical space, it might partition that into certain table spaces. So, you can specify in which table space you want that, or otherwise if you do not specify, it will go to the default. So, this is a allocation of space in the database, which will contain the schema object, the index in this case. Then you can specify the storage options. So, this specifies how the database should store the option. For example, how much should it allocate initially for this index schema object, and how should that space grow and so on. So, the options are that you can specify an initial size that is called the first extent of the object. For example, I have specifies 20 kilobytes, and then you can specify the next, which is the number of bytes that by which it will be extended when once the initial extent is exhausted, and you need to have more storage. So, next is used for the second extent, and further on you do not specify the extent, but what you specify is the percentage by which every time it will increase over the last extent. So, here for example, we had 20k, then 20k. So, the second extent was 100% increase, but from there on I am saying that the percentage increase will be 75. So, you have after these two you have 40k. So, 75% of that will be increased, right, 3/4 of that, which is, so it will become 30, increase will be 30k. So, it will become 70k. The fourth extent will do increase by 75% of 70k and so on, right. So, so you can see that by percentage the advantage you get is naturally as the index is growing, you would like to allocate more and more space in the subsequent extents, because it has a tendency to grow. If you feel that no, it is initially only there is a lot of things will be required, but the growth will be very low, then you could put PCT increase, percentage increase as a smaller value, like say 10%, 20%, right. So, you can also specify how much, what percentage of the data block in the table's data segment should be kept free for updates. I have said that no, nothing needs to be kept free. So, this is so what we saw here from this part is the storage specification, then the PCT free, and finally, you say, which is again optional, is compute statistics. So, that will tell you how your index is doing, what is getting indexed, how often, and so on and so forth. Now, to create index on two columns, you use the same command, but write two columns one after the other in the as your indexing attribute. Right. So, there are, I mean, if you use two columns, naturally the question is what will be used primarily and what will be used secondarily. We will talk about all that. Now, if suppose a query is going to sort on the function, on the name, right. So, you say upper name. So, an index on the ename column itself would not speed up this operation, because it has to sort, right, because sorting is changing the order, and the moment you change the order, naturally the index goes bad, it needs to be recomputed. Actually, it might slow down the call to this function. So, if you want to have this kind of sorting be applied along with the indexing, then instead of creating it on ename, you will have to create it with the function for each column value. So, that will speed up queries that use the function for searching or sorting, right. So, you will have to keep this in mind. So, these are the couple of basic things we have learned, how to create an index, how to give very key parameters to it if you want to control the space better, how to create index on multiple attributes, and how to create index when a function is intended to be used on the column on which you are indexing. So, you can also create index using the bitmap. We talked about bitmaps and hashing. So, here is an example, this standard student database, ID, name, age, address, etc. And we know that these two are attributes which will have limited values, right, because There are 2 possible gender values and 4 possible semesters as we were looking at. So, what we will do is for these 2 we will use a bitmap index, which is, as we said, that it is a long bit array as long as the number of records that exist in the table, and if a particular attribute is available in a record, then you put 1, otherwise you put 0. So, first record has 101 has gender as M. So, it is 1 here and the rest are F. So, you put 1 in those. Similarly, you do the same thing on semester, because there are 4 semesters and you will have for the first and second you have semester 1, for the third record you have semester 2, for semester 3 you have no record, and the last one. So, with this several of your computation, like you want to do select star from where gender F and semester is equal, gender is equal to F and semester is equal to 4. So, what you take the bit pattern of F, you take the bit pattern of semester 4, and all that you need to do is to do an ANDing. So, take these and take these, do an ANDing. So, you will get 0 0 0 1, which tells you that the fourth record only satisfies this condition. So, this naturally this kind of index speeds up operations when you have this kind of a property. So, all that you need to do is to say specify the bitmap field on which bitmap keyword to create a bitmap index, and rest of it is the same. Now, you can have multi-key access, that is what, because there could be more than one key, more than one attributes on which you want to index, because oftentimes maybe you use them in a combined manner, like you are doing it here. The select ID of the instructor, where the department name is finance and salary is 80,000, right. So, what could be the possible strategy? One possible strategy is to use an index on the department name only. I mean, just use the index on the department name. So, that will quickly find you instructors with that given department name finance, and then you do a normal test for the salary, right, because you have index on this. Alternately, you could have index on salary to find the instructors with salary 80,000 and then test for the department name, right. Or you can use department name to find department name index to find pointers to all records pertaining to finance, and similarly use index on salary, right. So, intersection of both sets are the set of pointers obtained, right. So, these are the different kinds of possibilities when you have multiple such. Now, if you use this as a composite index, a department name salary, then the question is in terms of indexing, indexing is basically creating a virtual ordering, right. Indexing gives you a virtual sorting on the data. So, what is that sorting rule? Sorting rule is, there is this order is important from left to right, and in this order whichever comes first is given the preference in terms of the comparison. So, if I order in this way, then the ordering is A1 A2 is less than, considered to be less than B1 B2, this tuple, because you have 2 values now, if either A1 is less than B1. So, you do not look at the other one, right. So, you consider that to be the earlier record, or if A1 is equal to B1 and A2 is less than B2, right. So, this is the way you arrange the dictionary. So, exactly you use that, and therefore, the order is important. So, the index order that will be created by an index which is department name comma salary is different from what will be created if it is salary comma department name, right. So, when you index with this kind of multiple attributes, let us say you have done an index on department name salary and you are trying to do this. So, so this can be used to fetch only records that satisfy both conditions. Right. Now, if you use separate indices, it will be less efficient because each one of them will bring more records than what will actually go in the final case. Actually, this will also be efficient in terms of this query. The difference is salary is less than this. Why it is so? Because in department and salary, the first preference is being given to department name. So, department name has the primary ordering. So, it will filter out lot more because it has an equality, right. Department name is finance. So, it is expectedly much less number of tuples within which the index second part of the index on salary will be used to get records less than 80,000. But if my query was different, just think of it, is department name is less than finance, whatever it means. I mean, it is not a semantically very meaningful query, but this is equal to 80,000. Then this will bring a lot more number of records, because primarily it is going to look at the department name, right. So, not the second condition. So, while you form your index, you have to also keep an eye on what kind of queries you are going to primarily look for, or what kind of, for which kind of queries do you need to do a speed up. You are intending to do a speed up using the using all your indexing mechanisms. Okay. Now, moving on, can anybody create an index? The answer is no, because creating an index has a lot of impact in terms of speeding up a few queries, which is true, but it may also impact in terms of various performance degradation in updates. We will discuss I mean, you can easily understand that, because every update will have to update the index. It also has implications in terms of the space that you use in the database. So, there are certain rights or privileges that you will need to have to be able to create an index. Otherwise, you will have to, I mean, for that you will have to ask your DBA to grant the privileges, or otherwise you will have to just work with the indexes that exist. So, you must have a index object privilege, and if the schema contains the index, must also have a quota for the table space, right. You can specify this much of table space I need. Then you will need to have that kind of a system privilege, unlimited table space and so on. If you want to create an index on a schema that is not owned by you, it is owned by someone else, then you must have create any index privilege. One is a create index privilege, one is create in. By create index privilege, you can create index for schemas that you own. With create any index privilege, you can also create schema that index for schema that others own. Similarly, function based indexes, which we saw in terms of upper E name, require the query rewrite privilege, and the query rewrite enabled initialization parameter has to be set to true for that. I am sure you will not retain so much of details from this description. All that you need to remember is you need privileges, and when you are actually working on the system, you can look up the system manual to see exactly what privileges you need and ask the DBA to grant you those privileges. DBA means database administrator, the ultimate authority. Okay. So, this was how you create indexes in SQL. Now, the question is, what should you index and how much should you index? So, if we step back a little, you will see that there have been certain basic design objectives we started with, and initially it was totally at the design level. So, we worked extensively on normalization of tables, which lead to reduction of redundancy, naturally consequently minimizes the possibilities of anomaly. It makes it easier to adhere to different constraints by various dependencies, and efficiency of access and update is better in a normalized design. So, this is what you do at a design time, but remember, design is done once. Once you have, I mean, you hardly ever change the design, because if you change the design in a live database, then all your data will have to be migrated and all those issues will come. So, subsequent to your design, what you have to keep doing to have a good database performance is to see how the data is physically organized and managed. So, that is the next thing we have talked about extensively, that is about indexing and hashing, what kind of index, what kind of hashes, all these will have to be. All these mechanisms have been given so that you can, based on what your database needs at the execution time, at the runtime, with the real data, depending on the idiosyncrasies of the real data, that will have to be designed. So, naturally, how do you know about how your data is doing? And these are the two tools that you have. One is collect statistics, as we say, compute statistics. So, which will give you variety of, on various tables you will be able to learn the patterns, which query is moving faster, which query is more frequent, what is slowing down a certain query processing or update processing, and so on. And based on that, you have to adjust the indexes to on the tables to optimize the performance. Now, unfortunately, unlike the normalization theory, there is no sound theory that can determine optimal performance, because it significantly depends on the profile of the data in the real world. Given the same basic normalized design from the constraints of the data, you could have variety of different actual profiles of the data, statistics of the data requiring varied different kinds of indexes depending on the data distribution. So, since we do not have a theory, what I would just show to you is a set of kind of rules. These rules are not not any rules like programming language rules, these are cast in stone. These are kind of guidelines which has evolved over a large period of experience that the community has gathered by working with databases. So, you should keep these rules in your mind and then apply them as appropriate in different contexts based on the statistics and adjust the indices, so that your database remains agile in its behavior all the time. So, I summarize, I start with the summary of 7 ground rules for indexing. Rule 0, indexes lead to access update trade off. The more index you have better access, more index you have, updates become slower, disk space becomes more. So, there is a trade off you will have to do. It is not that you can have a design by indexing everything, right, disastrous. But at the same time, if you do not index then anything, then your frequently asked queries will be unnecessarily slow. The second you have to look at is index the correct table, not index everything. Which table should you index? You have to answer that. Do you index every table, or there are certain properties that you could look for? In a table, what are the correct columns to index? Would you index on every column, every combination? That is explosive. So, you have to decide on the correct. What is the number of different indexes that you will have on each table? Right. So, this very these are more significantly common sense rules, but very significant in terms of actual execution. You may have composite indexes, and the order of the columns we have explained with this department name and salary example, that how the order of the columns become important in terms of the composite indexes. Then you have to gather statistics to make index usage more accurate, and finally, drop the indexes that are no longer required. Right? So, these are the 7 ground rules. Rule 0, indexes lead to access update trade off. So, you know that the query access results in a search. So, index will help. So, specific index on that field or the set of fields will help, and but update, any update, insert, delete, or even a value update result in the update of the index file also. So, we have, for that reason only we have seen all this self adjusting B plus tree structure to maintain the data. So, but it has an overhead or penalty. So, update is the overhead or penalty you pay for quicker access. So, having unnecessary indexes will cause significant degradation of performance, right. The index files could also occupy a lot of space. So, you have to have informed judgment to index, right. This is the basic first rule. Second says index the correct table, you know. So, this is a thumb rule being given, create an index if you create an index if you frequently want to retrieve less than 15% of the rows in a large table. Why? Why so? Now, this percentage is not sacrosanct, it will vary according to the relative speed of the table scan and how clustered the row data are. You can think of it in this way, that if the data is more clustered, you know, lot of values are together, then you will have the need to index only if you want to access a whole lot of data, right. But if it is very sparse in terms of clusters, lot of values are distinct, then even for small segments, small part of the data, small part of the rows being accessed, an index will help. The core idea behind this is index is good on distinct values. So, you have to make an assessment of how much of distinctness you have in your table in terms of those values. Index columns can also be used to improve performance on join of multiple tables. So, you will have to know what you want to join. And remember, while indexing a table, that primary and unique keys are automatically indexed by the database. You do not have to create indexes for that, but you might want to create an index on a foreign key, which can make your joins better. Last but not the least, if a table is small, you do not require an index, because it might actually have too much of overhead, that a serial scan in a small table would be fine. But then over a period of time, when you see that your query is taking too long, you know that your table have grown to from a small to large size where you will have to index it. So, it is a live scenario and you will have to keep managing that. Index the correct column. So, as I said, that indexes work well when the values are relatively unique, and there is a wide range of values you may have. Use a regular index. You have a small range of values like gender, semester and so on, seasons. Use a bitmap index. There is a kind of a tip to handle columns containing many nulls, you know. So, you will, if you want to deal with the non-null values, you will normally say that where column X is not null, right. That is a direct semantic way of doing it. So, instead of saying that, you could say something like this if you understand. So, what this is saying is minus 9.99 times 10 to the power 125, which means that it is an extremely small negative value. So, I think column is greater than this. So, expectedly whatever value you have in that column, obviously this is true for numeric column, not for others. For a numeric column, whatever value you have, expectedly it will be larger than this, except for those which are null, because those will never match in a comparison, right. So, why do you want to prefer this? Because if you use this and you have an index on column X, then it will use that index, but if you use this, it cannot use the index, because null cannot be indexed, right. So, there are these are some of the tips. If there are many nulls in the column and you do not search on the non null values, then you do not index. Long and long row columns cannot be indexed. Of course, long row is kind of deprecated now. It is a blob. You have I have talked about blob. That's a binary data. Right. So this is your rule number 2. Rule number 3 says that limit the number of indexes for each table, because if you have more indexes, more overhead is incurred. So when a row is inserted or deleted, all indexes will have to be updated. So you must check that you really need the indexes that you have. And if a table is primarily read only, you might use more index, because then the possibility of data changes are very few. But if the table is heavily updated, you must use fewer indices. Choose the order of columns in the composite index. We have already talked about this. Here is an example that I would like you to look at. Say there is a vendor table given here, and it has a vendor parts table. It has 5 vendors, and each vendor has about 10,000 parts, right. So in a query like this one, where you have part number as well as vendor ID, there is a possibility of using a composite index, right. So whether the composite index should be part number vendor ID or vendor ID part number, it should be part number vendor ID. Why? Because when part number has a large number of possible values, about 1000, whereas vendor ID has a very few possible values. So if you can come to the specific part number, then your reduction in the number of records that you will have to look for the vendor ID 1012 will be lot more, compared to if you had done vendor ID comma part number, where 1012 will have thousands of part numbers and you will have to look for 457 between them, right. So these are kind of the judgments which you will have to. This is all based on the profile of your data and cannot be generalized as such. So you have to gather statistics to know about all this. So I have shown how to use compute statistics, and you can also update and distribution of the value changes periodically by refreshing the statistics. You have to call these procedures if you are working in Oracle, otherwise you will have to see what the corresponding ones are. And drop an index, that is no longer required. It is quite obvious why you will have to drop that. And when you drop a table, then all indexes on that table are dropped, and if you do not want any index on a table, you can drop all existing indexes by drop any index kind of thing, and you need the privilege for that. So this brings us to the end of this module. We have now closed on our study on the indexing. We have learned how to create indexes of various types in SQL and what are the ground rules, the guidelines for indexing. Thank you very much for your attention, and we will meet in the next module.